Hello developers, let's start developing. So we're back with the second part of the 10th day of Advent of Code 2023 and we are still amazed, so to say. So we are within our maze and it has our loop and we actually need to see how many things are inside the loop, how many points are inside the loop. And this is defined in a relatively weird way. So we actually need to find the area that is actually enclosed inside the loop. The examples are quite nice. So we have this situation and I, the tiles marked with I means that those tiles are inside the loop and the tiles marked with O means that those tiles are outside the loop. And my first uh, instinct was, okay, this sounds like a flat fill. So we get a random point and we mark everything a random point not on the loop. We know what the loop is. So we get a random point not on the loop and we start marking everything out of it, and everything not marked has to be inside the loop because the loop kind of, if it's loopy, it will divide the space in two areas, that is things outside and things inside. Everything that's not outside is inside. We're done. It's gonna be some index math. We're gonna have a lot of plus ones, minus ones, and whatnots, but in general it would work. However, then we have this case. There doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between pipes is also allowed. Here, I is still within the loop and O is still outside the loop. So we have these things, which are technically, by whole index math, not reachable from outside. But these two are not connected, these two are not connected, these two are not connected, so basically this line is not, this line counts as not being enclosed by the map, by the loop. On the other hand, these two are also not connected, not connected, not connected, not connected, not connected, not connected, but this counts as being inside it. So we have some larger examples, and also it specified that the tiles don't need to be dots, actually they can be any kind of pipe not in the loop. So we need to do some counting. What I will do first, because now we just don't care about starts and ends, we need to find the loop. And for that, we kind of already have our part one. So for part two, we're gonna redo most of part one. Let's redo all of it. But we don't actually need the loop length now. We're gonna need const, what I do need, we need the loop itself. That is gonna be an array of pipes. And we're just gonna say, well, add the current pipe to the loop. Return -1. And now, once we have this, I will generate actually a new matrix, which is gonna be, let's just call it actually string array, which is an empty array. So, and I will just loop through this, something like this. This goes through our input pipes row by row and basically extract the characters. So I do have a method called print matrix somewhere. because it is quite useful. Look, loop matrix. No, I don't need loop matrix. I will need to find from the previous year where I had the loop matrix, the print matrix method, and that should be somewhere around here. Give me a few seconds. Yep, found it. So this is a print matrix function that we can actually use. Oh, it's over there, and we're just gonna print this matrix to see what happens. Oh, we started with a huge input. We don't want that. We want to start with a smaller input, but we might want to actually use this. Yeah. And we get this. But I don't want this matrix. I want something else because now we don't care about a lot less stuff, so to say. We don't care about twists and turns. We care about whether something is or is not part of the pipe. So we're not gonna take that. Here we will have not the pipe character. We don't actually need that. We're gonna say if loop has a pipe that is that, then we're gonna push X and continue. Otherwise, we're gonna push a dot. Let's see what happens now. If I'm correct, we should get X's in all the places when our loop is, except the last one. We forgot that one. So, yep. Now we need to say loop push current pipe once more because the last one is not pushed. And that was a horrible idea. Because now we actually do care about the twists and turns, because in this case we don't have a way to determine that the O's are different than the I's. Because we could just as easily be doing some kind of an other loop. This looks like a line of X's. We don't know that there was a gap here. No, we're gonna need some other kind of data structure to actually see. Because this line, if we take this, put it inside of, and just exchange O for a dot, and an I for a dot. So in this thing, let's see how it will look right now. There's just no way to see that these are somehow different than these. So we're gonna need to find out how are these enclosed. maybe one way to do this is to somehow transform this into this. Can we just grow our thing? Because even if we grow our, or zoom in, so to say, on our pipe, those things will still are still really inside because they cannot get out. Or maybe we can do some kind of a fill starting from a point and then digging it here. We're gonna need some kind of a metaphor because in this case, for example, this thing is out and very few things are in. Yeah, we're gonna need to do some thinking on this, and I'm getting hungry, so I'm gonna take a break. So, after the break and a lunch where I ate some sarma, and I heavily recommend it because it's one of the best dishes ever. We're back, and I have what I would think of as two different ideas. And I already mentioned one that I think I kind of like better because it might be a bit harder to implement and trickier even with all those pluses and minuses, but it might be more straightforward and easier to guess. What I want to do is actually expand, blow up, zoom in on this. So I will replace each dot with a 3 by 3 cell. So on the cell, and then if we have a situation like this, we will actually have enough space so that we can actually get through that. So let's just show it in Excel, for example, because that one is nicely squarish. So if we have the situation like this, JL, that's a J, that's an L, and that's a pipe, and that's a pipe, and that's a 7 and an F. Yeah, so 7 and an F. And it seems that we don't have anything. But what I will do, I will actually transform the 7 into this kind of thing. So I will add dots in all other places, and here we will have a dash, and here we will have a pipe. So this thing is kind of equivalent to the one before. So we're still entering here, we're still living here, but we do have some space in between. And the pipe will just be a pipe, pipe, and everything else is. So, on the other hand, oh, sorry, the other pipe, this one will be this, and the F square, the F position will be basically pipe F, noted O, F, and dash. So this is kind of equivalent to this, but we have a nice and empty array to go through. So in order to actually implement this, we might need to do some kind of things. Let's try it. So we have our whatever it is, the second part. We are getting our loop, and then we said we're going to create another matrix. So instead of, so if we have a pipe, we are pushing the character. Pipe.x, pipe.y, and this is a find, so we can actually take that. It's not a cell, it's a link in the loop. Let's call it like that. Then we push the character of the link. Let's see what we get now. So if we did it correctly, we will just get whatever we want to do. Yeah, so we have our thing. Looks like it should look. Yeah, that's the 7, that's the F. We're correct. Let's expand it. So this is the original loop. And now let's see, we're gonna have an expanded, which is one more thing. So we're gonna need to loop through all of these. So for, yep, for, not that, something like that, but for, again, we're gonna need to have the X as well. Come on. Yep. We can have the row. So for each of the items, we need to add what? It's not expanded, it's expanded, but how do we want to expand it? So maybe we just fill it from the very start. So we know that this thing is gonna be an array of what length? Well, the length will be 3 times the input length. Times 3. And then we need to do some mapping. We're gonna fill it with nulls because we have to fill an array in order to map it first. And then for each of them, we're just doing that with that much. And like this. Print matrix original, print matrix expand. And then we have an empty for loop. Let's see if it's 3 times larger. Seems to be. Okay, so we have all the empty spaces. And of course, we're going to expand an empty space with 9 empty spaces. So now we need to find the actual indices that we want to change. So, yeah, it's going to be something like this, but not really. It says the expanded x, the expanded y, and then it says like that. I'm gonna be shorter so we can just use these. And this will actually blow up the whole character. So let's see if that works. So an L is a set of 9 L's. But it's not what we want, but it's what we might get if we actually print it after we change it. And I want to see it this way. Yeah, so we have F dash L. This is 2 dashes actually, yeah, 2 dashes. J L. So we're just repeating everything, but we don't actually need to repeat everything. We're gonna need to do a lot of other things. And now we will do this in any case. But now we will have to say if the character is, no, it's not gonna be an S. We have 6 different. So let's do the easy ones first. If it's a pipe, oh no, oh, we have an error here. And we're gonna see it because the pipe is gonna be wrong. We need to find the center square. And you see that the pipes, instead of being in the center, are kind of off to the side. What we want to do is to have +1 here, because this is the center square that we want to use. And then we're going to go +1 and -1. So we are thinking about the center square. And the center square will need to be offset by 1 to get to the center of that. So if we are correct, so now we will have something else that we don't want to have, but it is definitely wrong. Okay? Oh, everybody else is wrong because we moved it over here, so each +2 should be actually be -1. -1. We're gonna copy and paste it so that we don't actually get -2 somewhere. So we have all the 9 combinations over there. Yeah, you can see we had 2 extra empty lines and it's supposed to be 3. Yeah, so now we're talking. You can see that the vertical dashes actually grow from the center to the center. Okay, if we have a vertical dash, if we have a horizontal dash, we do the other way around. So now this part should look better. Yeah, so those are kind of slim and everything else is kind of fat. And so let's see what we have. If we have an L, I'm not even gonna try to debug it, I'm just gonna see it visually because this is why we are developing this print matrix thing. To actually see if this works, and it looks okay actually, but I will just say the one above should be not an L, but it should be a pipe, and the one below should be, the one next to us should be a dash, so that we actually only have an L on the L. And now the L's actually look nice. It goes and it. So let's continue. If it's a J, and I'm gonna let it generate my code for me. Otherwise, we don't have any other options, and so we say unknown character. We should only have dots, which we don't need to cover because we already filled everything with dots. And we should have these 6 options. So let's see. Yay, this looks beautiful. And one other thing that I want to mention is that we are kind of guaranteed that the corner dots always remain dots. It doesn't matter. We're always changing data on an X basically, so the corner dots will always be dots. So what we can do, we can always just say that the 0, 0 dot will be outside of the set. So what we can do now, and we can see which are the ones that are not actually that are inside, which are that are outside. Now it's kind of obvious. This thing is inside, this thing is inside, all of it is inside, and all of this is obviously outside. So if we do a flat fill now, from starting from this point, it shouldn't be a problem to actually fill all of it. So now we need to implement a flat fill on the expanded array. Did kind of imagine that I do have a flat fill method, and to be honest, I'm gonna have those parameters. So this will be a dirty method. I don't write this often. Yeah, so flat fill will actually change the matrix that I'm giving it itself. So it won't waste data. It will change the actual data of the matrix. So I'm giving it a starting position and I'm giving it a fill string. And it says if the matrix, the character that I'm trying to fill in is not a dot, just stop filling. Otherwise, recursively call yourself for all different corners. And I'm just gonna add this because if y return and same for the y return. So if we went out of bound, we're done. Otherwise, this is gonna recurse all over the place and flood the matrix with excess. Let's see what we get after we have all of our excess. It got flooded. So everything, starting from the initial dot, everything that was available got flooded with that. So now we have our insight. The insight is kind of obvious. The dots, it's the dots. But how do we count them? Because now we generated lots and lots more dots. So none of this count, none of this count. Basically, we only have 2 dots here and 2 dots here that count. So now I will just loop through this expanded matrix but only count the dots if they have a specific property. So these are all the data that we have, let's say. So starting with this, we're gonna need to basically go back to where we were. And that is relatively easy. So we have three lines and three lines and three lines and three lines and three and three and three and three. And these are kind of like the previous ones. So here we don't, out of this line, to regenerate the original one, we have the first line is extra and the last line is extra. So all of these lines are extra lines that we actually added. So we're starting from the first one and the line and with the line of index 1 and then the line with index 4 and so on. And we can do that the exact same thing horizontally. So we don't need this or this or this or this or this or this. And here we don't want this, so we delete 2, move 1, 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 delete 2, delete 2, move 1, delete 2, move 1, delete 2, move 1. Yeah, so we have our kind of original line. Once more, delete, move, delete 2, move, delete 2, move, delete 2, move, delete 2, move. And this is another of our original lines, if you remember them what they initially looked like. They're here. Only now we have x's here, but let's consider this line, the third line and this line. We're going to process them as well. So the third line actually had this part that were outside but looked like they were inside. Look. Now it says they're inside. But let's do the same thing with this line. Delete 2, move 1, delete 2, move 1, delete 2, move 1, delete 2, move 1. We have it like this. So whatever is left, these are actually the center points of the 3 by 3 squares. And we can see how many of them are still dots. It's 4. And those are the inside dots. So we're gonna need to basically now scrunch this matrix. So we're gonna do something like this, and let's just fill it with whatever. So we're gonna fill them with question marks. Only it's gonna be 3 times larger. It's gonna be exactly the original length. But we're gonna loop through all of this. And we're not gonna do this, but I will just say, if y divided by 3 has a remainder, because we want 1, 4, 7, and so on, does not have a remainder of 1, then let's continue. Otherwise, we get the row. And the same thing here. So now we are just getting the row of x, and we're doing this, and we are copying over that character. Don't really care about what that character is, we're just copying it over. Row of x. let's print the scrunched up matrix. So we have the expanded and the flooded, and then we scrunched it up, and as you can see, we still have our line, we still have our inside outside parts, and we have our inside parts. So what we need to do, instead of printing it, we have print here, we have print here, we have print here. We're just gonna need to, well, no. Result is from the scrunch matrix, sum all of this, sum each row, and for each row, I don't have a count method. It would have been nice, but I will just filter and length. Filter an item where each item is equal to a dot, and then just get the length. And that is our result. So let's see if we are getting the correct result for this inside-outside thingy. It should be 4. Yep, it is. So let's do the larger example. Oh, so let's take this example. This example is kind of weird because it additionally has an S that starts at the edge. So we might uncover another bug. Let's see if this works. And note that we scrubbed all the unnecessary pipes. By the time we are generating the original array, we are scrubbing all the unnecessary parts, and this thing says that we have 10 items which are inside, and the task set, well, there are 10 items that are inside. It's this one, and then we have some kind of set of 8 or 9. 4, 3, 2, yeah, 9. So once more, let's try the huge input and see what comes out of it. So this thing generating the whole 3 by 3 expanding is definitely not an optimal way to do stuff. And seems that we have it's kind of big for our flat foil implementation. We need to change it to something better because this is a naive flat foil implementation. But we can also do something a bit different. Yeah. And that is trying to see what is the maximum possible stack size. What I will do, I will actually add here something weird. Says console log input dot pipes dot length of 0 times. Let's multiply this thing and return -1. So just we can see what is the total possible total area of the map. Come on, where do we have an error that link is undefined? Because when it is totally unreachable. Okay, now it is defined, but I'm actually checking here whether it's defined. So this is some kind of a weird Java TypeScript issue. Oh, 19,600. So that's how many dots we have. So I will remove this, and now I can actually remove this because here it actually knows that it's a pipe or undefined, but here it knows that it's a pipe. But if I when I put that return, it kind of got if. So I will just open my package JSON, try on my starting, and now I will need to Google how to add node options to TS node. And it seems that this is the correct way to actually set up a node to run TS node and to accept variables. And I will actually write, copy this and then, yeah, copy this and have it as a start proper. This is the actual one that we want to do, and this will be start extra. So now if we run npm start, then we will run into the Stack Overflow issue. Of course, the proper way to solve this would be to refactor Flatfill to actually use a queue or something like that, because it's not a heavily recursive thing. We can just take them one at a time. We don't have to recurse with a factor of 4. However, it usually works, as that is by far the simplest implementation of Flatfill. But we're gonna say start extra 10, and now we will have enough stack space to actually calculate all of that. npm run start extra to actually run it with a huge stack size, and now we have a depth of lots of things calling. It took us 3 seconds, and it says that the answer is 589, and that actually sounds about right. Let's see if it is. That's the right answer. So we managed to solve part 2 as well. It was scary, but it didn't scare us. So we have our first 20 stars from the first 10 days. So starting from day 11, we're going moving into the second decade where actually the harder tasks await. This wasn't even one of the hardest ones. So keep developing. Don't forget to mash the buttons and see you soon.